Hello everyone, and welcome to the very first tutorial on the fixed effect Bayesian single level analysis using standard probabilistic language. Okay, remember that from the previous tutorials we did explore the datasets, the longitudinal datasets for the Alzheimer. And now the thing that we are just going to do, we are just going to look into the fixed effects model. By the fixed effects model, what do I mean? I mean that I do not incorporate any variations that we discovered from our different groups of the group CDR scores, for example, or the gender, and we assume that the model that we create is not going to change from individual to individual. You remember from the previous course, when we are just working with the stand, we have to just specify the data sets. And in order to do that, I'm just going to call it data stand. I'm just going to call that the model A, because that's going to be the first model that we're just going to work with. I just call that model A, which refers to our fixed effect single level Bayesian analysis in the stand. The data sets, you remember, the input for the stand, you remember it from the previous course which I had on the probabilistic programming with the stand. It has to come in the format of a list. The first argument, if you remember, it has to just come necessarily as specifies the number of the observation there, which you know that the number of the observation in your data sets, which is 373 observation, it's the number of the rows of our data. This is going to be the number of the observation. And also, you remember, we had to specify our response variable and the predictor variables there. The response variable is going to be what? Is going to be essentially the normalized whole brain volume. I'm just going to call that as the NWBV, which you remember that in order to target it in the data sets, I'm just going to go with the data, attributed with respect to, I should say, with the normalized whole brain volume, and take it there. I'm just going to also take a quick note there with the hashtag sign that it's going to be the response variable. Okay, now, also there is one thing which is missing, and that one has to be the indication and specification of our predictor variable. We have only one predictor variable in our fixed model, which is going to be the age. I'm just going to go ahead, call the age. I'm just going to take the attribute shape from the data as the age, and I just going to get there, and I'm just going to go put the small notes there and call that with the hashtag sign the predictor variable. And also, I can just put the different notations here that this one is going to be the number of the observation. Okay, now, it seems that now we are at the stage to execute the line. You see that the line which is executed, it's essentially there. I shouldn't have just put the comma there, and now you see that we have the object created there, list of 3, and as you see, it's called the data stand model A. And if you click on it, you will see that your 3 objects, the first one is the number of the observation, is 373, and the normalized whole brain weight volume, which is going to be, you see that we extracted that features from our data sets, and each individual number is one of those normalized whole brain volume, and also the age, which the length of it is also 373, and you see the age is from 87, 88, and goes all the way. Okay, and now, at this stage, what we have done, we have been able to create the list, which is going to be the input for our stand model. The next thing is that we have to just go to create the stand itself. And in order to do that, I'm just going to go ahead, but before that, we have to make sure that in our packages, I have the R stand installed. You can simply scroll it down and check that if R stand package is on your system. You see that we have the R stand. You can just click on it in order to call the library. In case if you do not have it, you know that from the previous course that we had, you had to just Google it and copy paste the one which you have it from the GitHub, or you just call install packages with the dependency to be true and just execute that, I should say, on your environment. Now, as long as the RStan is ready, I'm just going to go to the file. I'm going to go to open a new file, which in that case is going to be a text file. You know that in your text file, you have to create at least 3 blocks, which is going to be the data, parameters, and also I'm just going to call this as a model. These are going to be the 3 datas, the 2 blocks which it's needed as a fundamental ones in order to start the stand file. And now I'm just going to go ahead and save it as, you can call it anything you want. You can call it model A. You can call it model A. I'm going with the AD, which stands for, I should say, with the Alzheimer. But the point thing is that you have to just put, I should say, stand next to that. Model A. Let's make it, keep it much simpler, just with the model A dot stand. And that's the key point here to remember. You have to save your file with the stand at the end. I'm just going to save it. It seems that stand, let me call that also AD. Okay, which shows that it's going to be for the Alzheimer. I'm just going to save the file. You see that when you save the file with the stand, the colors is going to change them. Okay, now what we are just going to do right now is that we are just going to spend the time to just fill out the blocks that we have here. In order to fill out the blocks, I'm just going to go ahead with the data. You remember that with the data, you have to just go ahead and make sure that whatever you have created in your list, you have to just put that in your data. It means that, first of all, I created a symbol and an object. In the list, it was n. I know that I put the semicolon next to that based on the syntax for the stand, and I just put this symbol there in order to add my notes. It's going to be the number of the observation. It's going to be the number of the observation. However, the thing which I know that is that it has to be an integer with the lower can be 0. I can have 0 observation. And that's the way which I designed and created the first argument in my data block in the stand. It was the first one which I can put a tick next to that. The second one, it was another object which we named it NWBV. I'm just going to also come here, say that NWBV, which stands for the normalized whole brain volume, and I'm just going to put the semicolon there and put this symbol in order to add my notes. It's going to be the response variable. However, what is that going to be? You see that in order to make it the computation more efficient, we are going to define it as a vector, which it has a length, and the length of it, it's going to be essentially the number of the observations that we had. And I put the tiny space between the length of the vector and the name and the objects of my response variable. We have talked about that extensively on my previous course on the probabilistic programming languages with the stand, and I hope that you remember that. And also, I'm just going to go up here and go back to the list which I have to see that I defined another object here, which it was called age. I'm going to go here, put the age, put the semicolon there with the double hashtag, with the double, I should say, slash forward to say that it's going to be the predictor. The predictor variable. Okay, now, and also I know that I define it also as a vector which has a length of n, and I put the space between them. And essentially by doing that, I have created the data block in the stand model, which I should say it corresponds one-to-one by all the objects which I define into the list in the R. And that's the crucial thing. The order It's not important, but we have to make sure that there should be a correspondence one-to-one between any objects that we have defined into the list with any items that we define it into, I should say, the data block in this stand. Also, we have two other blocks as the parameters and the models, and also that I think that's going to be a good thing if we just, when we come back at the next tutorial, we are just going to fill out these two blocks and add one more block, which is going to be called generated quantities. Okay, then I hope that you learned how to just create the data block for your project. Then when we come back, we fill out the rest of the blocks and add one more block into our stand model. Then make sure that you do not forget to save it. And when we come back, we continue with the other blocks as well. See you soon then.